This is the same principle of molecular attraction that allows geckos to cling to surfaces. The attraction between their feet and, say, a wall as I climb up a wall, it's because of these temporary induced dipoles. So what happens is the gecko's feet have these hairs that are have these molecules that temporarily generate these dipoles, and they attract the charges in the molecules of the wall, thereby inducing temporary dipoles in the wall. And so you have this induced dipole interaction. And that creates the molecular forces that enable the gecko to stick to the wall. And here's one more question we can ask on this topic. Which type of molecular attraction takes the least amount of energy to break? Ion dipole interactions, dipole-dipole interactions, dipole-induced dipole interactions, or induced dipole interactions? And the answer is D. These are the weakest, the induced dipole attractions. And we can see that this is because the induced dipole attraction is the weakest of the four, but only on a molecule-to-molecule basis. Remember, each hook on a strip of Velcro may be weak, but all the tiny hooks working together can provide for a significant holding power. It's the same idea. Each of these induced dipole attractions are very, very weak, so it doesn't take a lot of energy to break them apart. But when you have a whole lot of them, they can add together and create significant amount of attractive forces.